I am Kavitha VM, Assistant Professor of EEE Department, Emmanuel Sir JJ College of Engineering. Good morning to all students. Today I am going to take the topic Co-ordinate Systems. First of all, to describe a vector accurately and to express a vector in terms of its components, it is necessary to have some reference directions. Such directions are represented in coordinate systems. There are three types of coordinate systems: rectangular or Cartesian coordinate system, that is represented by x, y and z; cylindrical, then spherical. Cylindrical E phi z and spherical is denoted by r theta phi. First one, Cartesian coordinate system. This system has three coordinate axes x, y and z, which are mutually at right angles to each other. There are two types of systems: right-handed system and left-handed system. Right-handed system means if x-axis is rotated towards y-axis through smaller angle, then this rotation causes upward moment of right-handed in z-axis direction. This is shown in the figure right-handed system. Rotation of x into y component, that is upward direction. O is the origin. Next one, left-handed system. In left-handed system, x and y axes are interchanged compared to right-handed system. Rotation of x-axis into y-axis through smaller angle. In this, the downward movement of right-handed in the z-axis direction downward, representing a point in rectangular coordinate system. A point in rectangular coordinate system is located by three coordinates, namely x, y and z coordinates. Can be represented as p, x, y, z. Next one, differential elements in Cartesian coordinate system. Consider a point p, x, y, z in the rectangular coordinate system. dx equal to differential length in x direction, dy equal to differential length in y direction, and dz equal to differential length in z direction. Then the differential vector length dl is given by dx into ax vector plus dy into a vector plus dz into az vector. The distance of p dash from p is given by the magnitude. The magnitude of dl vector equal to root of ds square plus dy square plus dz square. Then the differential volume is given by dv equal to dx dy dz. Then the differential surface element ds is represented as ds vector equal to ds into an vector. The differential surface elements in Cartesian coordinate systems is given in the figure. dsx, vector representation of these elements is given as dsx, dsy vector, dsz vector. And base vector. For Cartesian system, the three base vectors are the unit vectors oriented x, y, z direction: ax vector, ay vector and az vector. Position and distance vector. Position vector of point P can be represented as r equal to x1 as vector plus y1 ay vector plus z1 az vector. Magnitude r is given by root of s1 square plus y1 square plus z1 square. distance vector PQ vector equal to Q vector minus P vector. This x2 minus x1 into AS vector plus y2 minus y1 into AY vector plus z2 minus z1 into AZ vector. Cylindrical coordinate system. The circular cylindrical coordinate system is the three-dimensional version of polar coordinate system. First one, plane of constant Z which is parallel to xy plane. Second one is cylinder of radius r with Z axis as the axis of the cylinder. Third one, a half plane perpendicular to xy plane. The ranges of the variables are R, 5 and Z. Say cylindrical coordinate system R, 5 and Z in xy Z directions. Then differential elements in cylindrical coordinate system. Differential lengths are dr, r, d, phi, dz. Differential vector length is given by dl vector equal to dr into ar vector plus r d phi into a phi vector plus dz into az vector. Differential volume is given by dv equal to r dr into d phi into dz. Vector representation of surface areas is given by dsr, ds phi vector, dsz vector. Then the relationship between Cartesian and cylindrical systems. Consider a point P whose Cartesian coordinates are x, y, z. Cylindrical coordinates are r, phi, z. At xy plane, x equal to r cos y equal to r sin phi. The transformation from Cartesian to spherical can be obtained by r equal to root of s square plus y square, phi equal to tan inverse of y by x, z equal to z. Third one, spherical coordinate system. The surfaces which are used to define the spherical coordinate system on the three Cartesian axes are: first one, sphere of radius r. Second one, a right circular cone with its apex at the origin. Third one, a half plane perpendicular to xy plane. The ranges of the variables are 5 and theta. This is the figure representing point P in spherical coordinate system r, theta, 5. Then base vectors. The unit vector AR is directed from the center of the sphere. Vector of point P can be represented as P vector equal to PR into AR vector plus P theta A theta vector plus P phi into A phi vector. Then differential elements in spherical coordinate system are dr, r d theta, r sin theta into d phi. The differential vector length dl is given by dr into ar vector plus r d theta a theta vector plus r sin theta d phi a phi vector. Then the magnitude of differential length is given by dl equal to root of dr square plus r d theta the whole square plus r sin theta d phi the whole square. Differential volume is given by dv equal to r square sin theta dr d theta d phi. Then the differential surface elements are given. The vector representation is given by dsr d theta d phi. dsr equal to r square sin theta d theta d phi and d s theta vector equal to r sin theta into dr into d phi. d s phi equal to r dr into d theta. Then the relationship between Cartesian and spherical systems. Consider a point P whose Cartesian coordinates are x, y and z. While the spherical coordinates are r, phi, theta as shown in the figure. In xy plane, x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. The transformation from Cartesian to spherical coordinate system are r equal to root of s square plus y square plus z square, theta equal to cos inverse of z by root of s square plus y square plus z square, and phi equal to tan inverse of y by x. Okay students, thank you.